Alright, beautiful people. We're talking about Hickesian demand curve today, which is otherwise known as the compensated demand curve. Oh, I think it's demand function, right? Okay. In the last class, we talked about machinal demand function, and we were able to derive the machinal demand curve and the machinal demand function for two goods, considering the utility function that we have and the budget constraint. So here, like I said in the last class, I was still going to use the functions that I used in the last video, okay, to explain how to derive the Hickesian demand functions for x1 and x2. Obviously, the functions are going to be different because when you're looking at the compensated demand curve, here your utility is constant, right? I've mentioned that times that number. Your utility is constant. The relative price of the commodities have changed now, so you're trying to figure out what is this cost you have to incur in order to maintain your old level of utility. So here, since utility is constant, it's going to be the constraint, right? And then your budget function is going to be your objective function. So I'm giving you x1, x2 as x1 alpha, x1 minus alpha, p1, p2 as whatever respective price of x1 and x2, and the consumer's income. Derive the Hickesian demand functions for x1 and x2. Take your constraints from the information given. It's going to be P1 plus M. It's not changing. Okay, so now what we are going to be adding is M, right? Being a function of x1, x2 equal to P1 x1 plus P2 x2, right? Plus lambda into bracket, then your utility function. So in the last video, what I just did was equate this to 0. So here you'll be equating your utility function to 0. Okay, so we'll be having u minus x1 alpha, x2 1 minus alpha, right? Okay, so this is equation. Let me just call this equation 1. This is actually equation 2 because I had an equation here before, so let me just call this equation 3. Okay, so if you look at this, then we start with a partial differentiation. So this shouldn't come to you as a surprise because what it happens is u equals x1 alpha, x2 1 minus alpha, right? Which was equation 1. So by the time you want to equate it to 0, so that u minus this equals 0. But you don't write it equal to 0. So that's just the format of doing this law. Okay. So from here, finding the partial derivative, the m, the x1 will be equal to p1. That's all you're done with this side. Then where's x1 here, right? So if you're having p1, there's a minus times plus minus alpha. x1 alpha minus 1, x2 1 minus alpha lambda. So this is equation 4. And I said it is Hickesian demand function that's kind of funny, right? It's funny. So the m, the x2 will give us p2 minus 1 minus alpha, x1 alpha, right? Then x2 1 minus alpha minus 1, that will give us minus alpha. Okay, 1 minus alpha minus 1 minus alpha. Then lambda equals, this is an equation 5. Then equation 6, the m, the lambda rather, will give us u minus x1 alpha, x2 1 minus alpha, which is equation 6. So from here, like in the previous video, they divide equation 4 by equation 5. No, before that, the first order condition says, FOC says that we should equate the m, the x1. So the m sets the m, the x1, and the m, the x2, and then the m, the lambda equal to 0. So that's first order condition. So when we do that, we are having p1 minus alpha whatever equals 0, and from there we eventually have p1 equals everything that is here, alpha x1 alpha minus 1, right? Then x2 x2 1 minus alpha then lambda, right? Then the second one is going to give us p2. Okay, let me waste space. We don't have much of it. P2 equals 1 minus alpha from there, 1 minus alpha into brackets x1 alpha, x1 alpha, x2, x1 alpha, x2 minus alpha, x2 minus alpha, then lambda, right? Then now the last one here is just the utility function again. U equals x1 alpha, x2 1 minus alpha, right? So x1 alpha, x2 minus alpha. So that's about that. So what we just have to do from here, let me name these equations. So 6, then we label them 7, 8, and then 9. So we divide equation 7 by equation 8. Okay, divide equation 7 by equation 8. So when we do that, we have P1 equals alpha x1, alpha minus 1, right? Then x2 1 minus alpha lambda, right? Divided by P2 equals what's P2? 1 minus alpha, right? x1 alpha, x2 minus alpha, x1 alpha, x2 minus alpha, then lambda. So lambda takes away lambda. So just like in the previous class, this is telling us that P1, P2 is equal to mu x1 over mu x2, right? So that's what it's telling us. Okay, so I don't think that should be a problem. Basically, what we are looking for is a consumer equilibrium where the equation and the stabilization of the difference from. So, if the statement that P1 P2 is equal to our marginal rate of substitution, that is all what you're supposed to have. Okay, so from here, just like in the previous class, I'm going to make x 1 minus alpha to equal z. Okay, and in fact, I think this is more critical in this particular class. So, from here, I'll be having P1 over P2 equals z, right? Then x1 alpha minus 1 minus alpha. Okay, then x2 1 minus alpha plus alpha. So minus alpha comes up, it becomes a plus. Okay, so P1 over P2. Somebody is saying, oh, come on, it's the same thing, right? You know, right? x1 alpha minus alpha takes away each other, so we have minus 1, then x2 minus this takes away each other. So from here, I can easily make x2 the subject of the equation. So I divide both sides by z x raised to the minus 1. So when I do that, so I'm having x1 equals P1 over P2 divided by z x raised to the minus 1. And obviously, x raised to the minus 1 is 1 over x, right? So I'm essentially saying this. Okay, x raised to the minus 1 is just that. So x1 will then equal to P1 over P2 times x over z, which is okay, I think something might be wrong. Is this okay? This is x2, right? Okay, nothing is wrong. x2. Okay, and this is x1. So here, what I have is x2. Okay, and this is x1. So x2 is eventually P1 x1 divided by z P2. Okay, so I could just conveniently call that equation 10. Equation 10. Okay, so now what I have to do is to substitute equation 10 into the constraint here. And that's where things get a little bit funny. So when we substitute equation 10 into that, so substitute equation 10 into equation 9. then into equation 9. So at first, let me confirm this naughty guy here. So what I did here, so as 1 minus alpha not equal to z. Over here, what I'm doing is the reverse. So I understand why I said it's just reality. So that's what it's supposed to be. So substitute equation 10 equation 9. Substitute equation 10 is equation 9. So we have u. That's why math is so beautiful. Anyhow you do it, you're going to arrive at the same answer. x1 alpha, right? Then x2, 1 minus alpha. x2, this guy, right? So x2, p1, x1 over zp2, where zp2, 1 minus alpha. Wow. So how are we going to get x1? What are we going to do to get x1? So you just have to pay attention. So what you have in this bracket, this is z. Let me show you something. So if you have, let's say you have 5a raised to power 2, you can take them out to become 5 squared, right? A squared. So that's meaning better still 5 squared and into brackets. You leave your a squared outside like that. So this is going to become 25a squared, whatever way you do it. Alright, so that's what I'm going to do here. So this would be u equals x alpha times x1 alpha times x1 1 minus alpha. So I brought out x1 on its own, right? So I'm left inside the bracket, we are left with p1 over zp2. They are still left with their own 1 minus alpha. Okay, so it's a simple manipulation. So u equals from your indices alpha plus 1 minus alpha. So that's going to give us 1. So x alpha minus alpha will take each other out. So you are left with x1, okay, into bracket p1 over zp2, right? 1 minus alpha. So how do we get x1 out of here? Okay, so I'll further simplify these things. Okay, so what I'm supposed to do is let me just do something like this. U equals x1, then I bring each and every one of them out. So you have p1 1 minus alpha, right? And you have 1 over z 1 minus alpha, then you have 1 over p2, right? 1 minus alpha. So the crazy things are about to happen. Okay, let's proceed. So u essentially is equal to x1 p1 1 minus alpha over z 1 minus alpha, then p2 1 minus alpha. Okay, so let's just from here, just imagine this wasn't there. So from here, get p1 1 minus alpha, then z also has this power, then p2 also has p2 also has that. So it's like saying 3 a over 5 squared. So this is more or less 3 squared, a squared over 3 squared over 5 squared. Alright, so which is going to give us 9a squared over 25. Okay, so allow each and every one of them to carry the power, so it's all belongs to them. So p1 has 1 minus alpha, z1 has 1 minus whatever. So from here, we cross multiply. So you have u z 1 minus alpha, p2 1 minus alpha equals x1 p1 1 minus alpha. Okay, so x1 would be equal to u z 1 minus alpha, p2 1 minus alpha divided by p1 1 minus alpha. Okay, so from there, x1 equals, okay, if you look at it, they all came back to carry 1 minus alpha, right? So u is going to be equal to u into brackets p 2 over p1 1 minus alpha. Yeah. Yes. So p2 over 1 minus alpha. But recall that z is what? Alpha over 1 minus alpha, right? So x1 will eventually be equal to u into bracket alpha into bracket alpha over 1 minus alpha. Okay, z is like kind of standing alone. Then p2 over p1 1 minus alpha. Okay, so u alpha p2 over 1 minus alpha p1, right, equals that. So this is the Hickesian demand curve, Hickesian demand function for both x1. So this is what we are going to. Okay, so I could decide to like call this equation. It stopped at 9. Okay, so let me I could as well call this equation 10. And this is equation 11. So we substitute equation 11 for us to get x2. Recall that where is x2? Okay, x2 is here, right? For us to get x2, so what are we going to do? We are going to substitute equation. Okay, I have equation 10 here. So this should be equation 11 and 12. So we substitute equation. I'm looking at should I substitute equation 11 to make things easier? So this is x2. Okay, substitute equation. Okay, let me use 11. So this is equation 11 into equation 10 because this one has z and that one also has z. Okay, let's see what we're going to get. Substitute equation 11 in equation 10. From there, we have p1, p1. So we have with x2. So x2 equals p1 x1, p1 over zp2, then x1 is now all of this then u into brackets zp2 over p1 1 minus alpha. Okay, so that one x2 is 2 over p2, 2 over p2, x1 over z. So z is here, and this guy is x1. So I don't think, okay, I did a mistake. This is 1 minus alpha. The utility doesn't share in this power. Okay, so from there, x2 would be equal to take u out, u p1 over z p2. Then if I decide to take each of them out, so here times z raised by 1 minus alpha p2 raised by 1 minus alpha, right, divided by p1 raised by 1 minus alpha. So your ability to play with indices. So you have x2 equals u, then there's p1 here, so this is going to be p1 raised by 1 on its own, right? Then since it is subtracting this minus 1 minus alpha. Oh wait, let me make it a little bit easier. Although it's going to consume space, but let me just kind of do something for you to see. So you have u p1 over p1 1 minus alpha times like p1 here, then you have z 1 minus alpha divided by z raised by 1 here, then times P2 1 minus alpha divided by P2 raised to power 1. Yeah, P2 1 minus alpha, then you have P2 here, P2 raised to power 1. Right. So I think it is easy to understand from there. So S2 now is equal to utility function, then P1 1 minus alpha, right, times Z 1 minus alpha minus 1. Okay, then times P2 1 minus alpha, right, minus 1. So x2 is equal to up1 1 minus 1 plus alpha. This becomes 1 minus 1 plus alpha. And 1 minus 1 plus alpha is just alpha. Then z 1 minus alpha minus 1. That's z 1 minus alpha, right? And P2 1 minus alpha minus 1 takes away 1 minus alpha. So x2 would give us up over up alpha z raised to power minus alpha is the same thing as z alpha, like over z alpha, like times 1 over z alpha, then p2 alpha. Okay, so that's what we are going to be having for this guy. So x2 from here will then be can just put everything in brackets, p alpha, right, divided by p z p1 p2 everything raised to power alpha. So so that's what we are supposed to get. If you look at it again, you can see that there is a negative relationship between price and x2. So to kind of finally simplify the whole thing, so we have x2 equals u into brackets p1 over, recall z is what's z again? Alpha over 1 minus alpha, right? We have alpha over 1 minus alpha p2 everything raised by this. So simplifying this guy, you have x2 equals u. This is more or less p1 divided by alpha p2 over 1 minus alpha right raised by alpha. So x2 equals to u into bracket p1 times 1 minus alpha over alpha p2, right, raised by alpha. So x2 equals u into brackets 1 minus, I'm running out of chalk seriously today, 1 minus alpha, right, p1 over p2 over alpha p2 everything raised to power alpha. Okay, so 1 minus alpha over alpha p1 over p2 everything raised to power alpha. So that is lucky me. So that's about that. Okay, so here you have the Hickesian demand function for the x2. Okay, so you don't understand this very well. This might be a problem, but no, you're cool, right? You're cool. So after this, what you have is an assignment, and the assignment is for you to find the Hickesian. So this is your assignment. Assignment is much more simpler. So your utility function is u equals xy. Okay, and your coordinate constraint is still the same thing, p1 x1 plus p2. Should I use x1 or I should just use x and y? Okay, xy, right? So you have so you'll be having p1x plus p2y. Okay, so here you have to find the Hickesian, find the Hickesian demand function for with x1 for with x and y. Okay, so that's the end of this particular video. Hope you enjoyed it. Yeah, take your time, please. Take your time, sit, relax, be cool, eat good food, take enough rest, then sit down with this stuff. Don't just look at it and think you understand it, just pick up a pen and start to write it down on your own. So little by little you are going to get it. And some of you are not going to get it immediately you see the video, and that's fine. Just know yourself, understand yourself pretty much. So that's that about Hickesian Demand function and whatever. If I have the time so I'm going to I think there's this other aspect of it where you'll be giving figures to calculate the demand functions out and something like that. Okay, but I'm going to go into that, and I don't know when that video is coming in particular, but it should come. So after this, I think I'll likely be moving into game theory from this video. Alright, so for our students, it's not as if for students of the School of Economics, it's not as if after the class they are jumping into game theory. No, but I'm just talking about myself. So I might be recording the video on 3 by 3 game theory. So see you later.